My name is Bethlehem Abebe, and I'm currently working in Dr. Balunis' lab as a McNair Scholar. The focus of my research is to determine if there's a correlation between defensive symbionts against fungal pathogens among genetically similar Lysingeria strains. These bacterial strains were collected from the accessory nidamental gland of the Hawaiian bobtail squid. Female squids provide a consortium of bacteria into the protective coating of the eggs in order to provide them with protection from fungal fouling. My research question is, are there significant differences in the metabolite profiles of extracts from genetically similar Lysingeria strains? If so, is it driven by the difference in specific gene clusters? I divided my project into 3 subgroups in order to answer this question. The first phase was to use comparative genomics to identify which strains were considered genetically similar. By generating the ANI values of each of the 9 bacterial strains being studied, we were able to group them based on their genomic sequences. The next phase was to compile metabolite profiles in order to identify chemical differences amongst each of the strains. The final phase was a bioassay that looks at fungal growth inhibition when each of the bacterial strains were exposed specifically to Candida albicans. The reason why I chose Candida albicans is due to it being a common human pathogen. Each of the portions of my project allowed me to understand the relationship between similar and different gene expressions and how they impact what secondary metabolites are produced. Research regarding the production of natural metabolites and their behavior in the environment is important to pursue because of their potential to discover new antimicrobial compounds.